Welcome to the volume of a sphere, 14.6. So this is a cone. The volume of a cone is 1/3 pi r squared h. So it says use 3 for pi, so we're going to approximate it. 1/3 times 3, the radius is 4 squared, times the height. The 3's cancel. 4 squared is 16, and all I have to do is 16 times 12. 2 times 6 is 12. This is 32. 1 times 16 is 16, and I'm getting approximately 182 cubic inches. Now, what is that shape? That is not a circle. That is trying to look like a ball. The math word for a ball is sphere. Now, a sphere is a ball, or a globe is a sphere. To draw these, you draw a circle, and then it's interesting that you just with your eye draw an oval inside, like that, and it makes it look 3D. And if you put a center for your sphere, and then that's the radius of the sphere. Now notice, we had a height. For cones and cylinders, we had a height and a radius. For spheres, we're just going to have a radius. We're not going to have a cone. I mean, not going to have a height, per se. So how are we going to, what's the formula going to be for a sphere? Right? The air inside a basketball is measured as the volume of that air. All right, so this is the formula for a sphere. Volume equals 4/3 pi r cubed, and we're going to go over why it is that way. So it says approximate the volume of the sphere. You may use 3 for pi. Oh, isn't that nice? So we're going to do, right, 4/3, right, it's exactly 4/3 pi r cubed. Now the reason it's cubed is because there's no height. So it's really r squared times height, and you'll see that in a second. So 4/3 said use 3 for pi, and the radius is 5. Now 5 cubed is not, right? What's 5 cubed? 25 times 5, which is 125. So this is approximately 4 times 125. 4 times 5 is 20, 2 times 4 is 8, plus 2 is 10, and I'm getting approximately 500 cubic inches of stuff, air, right? Volume is typically either gases or solids, all right? So air is done in cubic inches, so are other gases. Typically water is not done, water and other liquids are done in gallons and quarts, not cubic inches, but they can be. All right, so find the volume closest to the correct answer. So it's 4/3 pi r cubed. So we're going to approximate this. So we're going to use 3 for pi, since we don't have to get it exactly. And the radius is not 20. That's the diameter of the sphere. The radius is 10. So 10 cubed. 10 times 10 is 100. Times 10 is 1,000. So it's approximately 4 times 1,000. 4,000 cubic inches. And the one a little bit more than that is 4,180 cubic inches. So what fraction of a sphere is that? Well, hopefully you see that that's half a sphere. So it's 1/2 times 4/3 pi r cubed. And the word for half a circle is semicircle. The word for half a sphere is hemisphere, right? And I'm spelling that wrong, hemisphere. We live in the northern hemisphere in the United States, and so a hemisphere or half a sphere, right, is also the shape of a bowl, right? A traditional shape bowl is a hemisphere, half a sphere. So 1/2 4/3 pi r cubed. It says you get to use 3 for pi, so we're estimating this. And the radius here is 2, so 2 cubed is 8. Can I just write 8? All right, so I can cancel the 2 with anything up there, but I'm going to cancel with this 4. I can cancel these 3, and all I get is 2 times 8. I get 16 cubic inches in this half, or hemisphere. Right, 2 times 2 times 2 was 8 for the radius cubed. The sphere there is trapped in a cylinder with the same radius and height. Write a formula for the volume of the sphere using h. So we're going to replace the radius with h, or at least one. We're going to one of the radii with h, and you'll see that here. But remember when we did this for a cone, right? For a cone, the cone occupied 1/3 of the space there. What do you think the sphere occupies, right? What fraction does the sphere occupy of the cylinder? Let's see if we can prove what it is. So it's 4/3 pi. I'm going to put r, but now I'm going to replace one of the r's, right? It's r squared times r for r cubed. I'm going to replace one of the r's with h. Now, how am I going to do that? Well, let's look, right? This distance is the radius, right? Same as that distance. So that distance to the top is also radius. So the height here is actually the diameter of the sphere, right? If the sphere just fits in the cylinder, the height of the cylinder is the diameter, or 2r for the sphere. Now, right, the height is 2r, but we can divide both sides by 2, and the radius is actually half of the diameter, right? That the height is the radius of the height is the diameter of the sphere, which is twice the radius, or the radius is half the height. So I'm going to replace this 1r with h over 2. Now let's simplify things and see what we get. Well, this 2 cancels with this 4. And what's our new formula? Volume equals 2/3 pi r squared h. Oh my goodness. All right. The sphere is 2/3 the size of the cylinder, right? The cone, right? Cone was 1/3 the size of the cylinder. The sphere is 2/3 the size of the cylinder. We just don't use 2/3 pi r squared h because normally there's just not an h there. There's just the radius cubed. So I just told you which one's the biggest, which one's the smallest. All right, so let's look at this. Right, the cylinder is the biggest. All right, pi. So this is the greatest. Right, it's pi r squared h. The next biggest is the sphere. The sphere is 2/3 of pi r squared h, but we use 4/3 pi r cubed as our formula. And the least is the cone. All right. So the cone, the least is the cone, which is 1/3 the size of the cylinder. Now also notice that if I cut this sphere in half, right? If I cut it in half and make a hemisphere, half of 2/3 pi, right? Then the dish and the cone have the same exact amount, as long as you're level with the top. They're both, right? Half of 2/3 is 1/3. Then they're the same. The whole sphere is 2/3 of the cylinder. The cone is 1/3. A dish would be 1/3 the size of that. All right, so we're going to find the volume of air inside a basketball. So I gave you a little hint here so we don't reach for a calculator. So volume of a sphere is 4/3 pi r cubed. So we're going to be approximately 4/3. It says use 3 for pi. That lets us cancel right there. And the radius is not 9.4. That 9.4 is the diameter of a regular basketball. So we got to do what? We have to divide it by 2. 2 goes into 9, 4. Decimal straight up, 4 straight down. 2 into 14 goes 7. Oh, 4.7 cubed. Oh, that's why I have this hint here. 4.7 cubed is around 104. So it's 4 times 104. And 104 times 4. 4 times 0 is 0 plus 1 is 1. Is approximately 416 cubic inches of air in a normal basketball. Right? And the number one thing, remember, if I give you the diameter, you almost always need a radius for volume. All right. So now, Find the volume of ice cream that would fit in all the dishes. Leave pi in your answer. Now there's a bunch of ways you could do this, but each one of these is half of 4/3 pi r cubed, right? So there's 3 of those halves, right? There's 3 of those halves, so I'm going to do 3 times 1/2 times 4/3 pi r cubed, right? There are 3 halves. So the 3's cancel, and the 2 cancels with the 4 and becomes 2. So the volume here just becomes 2 times pi r cubed. Come on, pi r cubed. So I need, it says leave pi in your answer, so I just need the radius cubed. The radius is 2, so 2 cubed is 8, and 2 times 8 is 16. This is 16 pi cubic inches in these 3 hemispheres. Right, so there's 2, right, of these 4/3 pi r cubed, and we're going to estimate 2 of them, and we're going to use 3 for pi since we don't got to get it exactly, and the radius of both of them is not 12, the radius of both of them is 6. So the 3's cancel, and 2 times 4 is 8, but 6 cubed is 6 times 6 is 36, times another 6 is 216. And now I have to do 216 times the 8. Let's see, 6 times 8 is 48. 8 times 8 plus 4 is 12. 8 times 2 is 16 plus 1. I'm getting 1,728 cubic inches, but I used 3 for pi, so I'm too low. It must be 1,800 cubic inches. Good luck with the homework.